Hey guys, what's up? It's Christian here, and I wanted to bring back an old video I made that had a whole lot of hits, and I kind of wanted to elaborate on it. And what this video was the one where I kind of controlled a pneumatic piston with an Arduino board. And so I noticed I left a lot of that stuff out. Also, I forgot to put a description down there. So I just thought I'd make a whole nother video, a little bit more in depth. And it's not just going to be the pneumatic cylinder and stuff like that, but it's going to be like Arduino, a little bit of electronics insight, just everything you might need to know to get started with this stuff, and a little bit of extra information just so you can kind of build on what you learned today. So if you want to go skip to the part where I tell you how to actually set up the piston, then there'll be a link in the description where you can click to just go straight to that. But if you want to learn a little bit about Arduino, then stick around and watch the entire video, and by the end you should be familiar with the hardware and software of all this stuff. And this should everything I'm going to include should be crucial to building a lot of things you want in your haunted house. So basically I'm going to start by showing y'all, what an Arduino board looks like. Now this is an Arduino Uno that I have right here, and this is actually how I got started doing Arduino, was with this Sparkfun Kit. As you can see, there, Sparkfun. They have this kit you can buy that's actually pretty descriptive, and it kind of tells you just, it gets you started. It has a bunch of little electronics, some little projects, and a really good manual, and that's really how I learned Arduino. It's really helpful, so if you really want to get into it, I'll leave a link in the description for that kit as well, and some of their boards. This is included, has a breadboard and the breadboard and the Arduino. So basically, if you look up here in this top row, these big rows, so you're gonna kind of find, this is like what I consider kind of the top of the board. Whenever I hold it, I consider the power part to be on the right side and this to be the top of the board. So up there you're gonna find all your digital pins. Now these can take inputs and outputs, and there's also gonna be some ground. Now whenever I say ground, it basically just means it's a negative. So there's positive and negative in power. You probably know that already, or at least in direct current. It's a little bit different with alternating current, but we're going to be focusing on direct current today for this video, because that is what most electronics use. Like your computer converts AC to DC with a little transformer and some other electronics that do that. But this all will be focusing on some direct current. So there's some extra pins up there, but I'm not going to get into that because they're not really crucial to probably what you're going to be using. But like I was saying, the top row are all called digital pins. Now basically, those just mean they're binary pins. They're PWMs, and you'll see that written on the board. Digital PWM pins. PWM. Now those take either like a 1 or a 0. In my last video I talked about having it high and low. High being on and low being 0. So the difference between the digital pins and the analog pins, and if you know, like analog kind of means like numbers. So analog pins can be a bunch of different, oh my god, the cat is up here scratching the camera. Stop that. Look at this. Get in the video. Famous Micah. You're going to have analog pins on the bottom, and those are going to take a various amount of numbers. So you might want to connect something like a potentiometer to that, because potentiometer can have a whole bunch of values. For today, we're just going to be focusing with the digital pins, but yeah, so if you want to have like a light turn on with a button, now you can use the analog pins, but I would go with some digital pins because it's just on and off. The switch is either on or off, the light's either on and off. If you wanted to dim an LED and like change the power output that was going to the LED, you would use an analog pin so you could change that amount of power. So then you're also going to find on the bottom, just to the left of the analog imports, you're gonna see imports, yeah, I guess. The analog just ports. you're gonna see all your power ports. You're gonna see 3 volts and 5 volts. Now the main voltage that an Arduino is gonna work with is 5 volts. And 5 volts should be enough to do stuff like trigger a solenoid and, you know, power a switch and stuff like that. And you're not gonna fry electronics too badly with 5 volts. Now, not all electronics you can fry with that amount. I have actually fried Arduino boards before. But that was really for putting like 9 volts into it. But yeah, so we're gonna go with the digital pins. So now to get started on that digital pins concept, I want to do a small project where we're gonna add an LED to this breadboard, and then we're gonna control the LED with a little button switch. Now, there are a bunch of other different types of triggers that you can use. A lot of these ones are going to use analog because they're going to have multiple values. For example, this is like a gyro sensor. It's like in your phone knows which orientation it is. This is basically the same thing. This is an ultrasonic sensor. It measures distance of things. There's like a joystick controller, but we're going to stick to a simple button because that's easy to maintain and manage, and it's easy to learn from. Now here I've done like a little simple circuit, and I will put a schematic up on the screen so y'all can see a little bit better what's happening. But basically we have 5 volts and the negative lead going to the breadboard, and then we have a resistor, a 330 ohm resistor in there just so we don't burn out that LED. And then I have the positive current running through the resistor to one lead of the LED, and then the negative current is going to the button, and then the outlet of the button is going into the negative lead of the LED. And so when we press the button, the light will turn on. But that's all with a circuit. Now right now we're using the Arduino for is just to send basically power. We're just using it as a power system. So what if we wanted to have the computer say if the button's being pressed or not? Because right now, I mean, just having the button pressed is just completing the circuit. But what if we had the button being pressed completing a circuit inside the computer module that is in turn telling the computer that, oh, the button's being pressed, we need to talk to the LED now and turn it on. So it's a little bit different. So I'm going to show you guys how to set that up, and also the Arduino code. Okay guys, so basically what I've done here is I have some 5 volts just running into the positive connection of this strip of the breadboard, and then just a negative ground voltage running here. Now let me talk about a little bit different that we changed with the circuit. So if you look, now we're going to have 2 extra pins or connector leads going into our digital on and off switches. So basically one of them is going to be going to the positive lead of the LED, while the negative lead goes to the negative ground connection that we have in our board. Now that ground is going to be constantly ground. It's always going to be ground. We're not changing that. But this positive voltage coming out of the digital is going to be changed, and the computer is going to either say send a current out of this digital pin into the positive into the LED, or don't. So we're going to be writing that in our code. Now we have this other one, which is basically going to be taking an input. It's going to be asking itself, can I feel a 5 volts current going into me? So we have on one end of the button, we have right here, we have some negative voltage going in to the button, and then we have this going with this lead that when I press the button is going to connect these two, that is going into the digital pin, which is asking, it's waiting to ask for a signal saying, am I sensing 5 volts, which is on. So I'm going to show you guys how to code that. Okay guys, so today I'm going to show you how to start this really simple code. Now the first Arduino project, it was working on just the button and some thoughtful and mindfulness to where power was flowing. None of the Arduino computer system was doing any of the work, but now in the second build I made, the Arduino was doing some work. So let's start and let's get a little briefing into code. So we need to start by telling the Arduino about our LED and about our button, because it doesn't know anything at this point. So I'm going to start by telling us that the Arduino board that we have an integer, because if we look at the digital pins, they're categorized by numbers. So a number is an integer. So I'm going to put int for integer, and I'm just going to call it LED, because that's what it is. Now we put the LED in pin 7, so I'm going to say integer LED equals 7. So this basically means whenever the computer thinks of LED, it thinks of 7. So if you type in LED, it's almost like typing 7. Now we need to put a semicolon at the end, because that is basically like a period for the computer, telling us that that is the end of the line, and it's done with that command. So let's go down and do the same for our button. So int or integer. Now I'm just going to do but for button, and then we had button in pin 11. Semicolon, can't forget that, it's very important. Now let's move down. This is void setup. Basically, it's exactly what it says. It's a setup. So it's going to happen once. It's going to basically brief the computer on what it needs to be looking for and what it needs to know before it starts the main section, which is our loop, which I'll get into more in a minute. So we need to first use a code line called pinMode, which is basically letting the computer know that we're going to be using some pins, and we're going to put LED, and so it's considering the fact that we're dealing with pins, and now we've put in this LED. So now that we know that LED is 7, so the computer basically sees pinMode 7. So then we're just going to put a comma, and we're going to put output, because the LED is our output. And things like these printout things, they aren't really common sense things, they're just things you need to memorize, and so that's what we're going to be briefing you over. These are the important ones that you're going to be knowing and need to know for your haunt careers or any project you might be doing involving simple actuators and button switches. So now that we have the pin mode for the output, we need a pin mode for the input. So we're going to put pin mode again. This time we have button, so but, which basically means 11. So pin mode, the pin 11 is our input. Semicolon. So now the computer knows that we're talking about pins. We're going to be using pins on the board. And pin 7, because it knows it's a pin because it says pin right here. And pin is basically just those connections in the board, like just the sockets in the board. All those rows of digital sockets are basically called pins. Pins are more of the thing you actually stick in there, but we call it that. So pin mode 7, or what we've renamed it and told the computer to remember it as, LED, is an output, which it is, and but is an input. So let's start and go down to our void loop. So basically we need to ask a statement of the computer. We need to say, is the button pressed? If so, it has to do something. So we're going to do if, and then we're going to start parentheses, because the if statement, if you will, is going to be encapsulated in this parentheses, so the computer exactly knows what it's guessing for or looking for. So we're going to put digital if. Now another thing I want to mention is this thing that in coding is called Camelcase. Basically that's the first word, there are no spaces, and the first word is lowercase and the second word is uppercase, or at least the first letters. That is pretty common, so you'll see it up here in the pin mode for simple one-liner commands like digitalRead. So now let's continue with the code, or the if statement we're working on right now. It says if digitalRead, and we're plugged into a analog pin, so if we were dealing with we're plugged into a digital pin. If we were dealing with an analog pin, it would be an analog read, which would look a little bit different, but basically it's the same concept. But we don't really need to worry about that in this tutorial. I might make a more advanced tutorial later. So we have a digital read because it's in a digital pen, so the computer is going, or the Arduino computer is going to read the digital pen. So we need to tell it which one it's reading. So we're going to put BUT, button. It needs to read the button. Now button is also 11, so it's reading pin 11. Now, in the video, I don't know if you noticed, but I was talking about how digital pins have two values, 0 and 1. This would be high or low, on or off, just like binary. So I'm going to use the term high, all caps. So if digital read button, if the digital read of pin 11 is high or has current or is on, we're going to start brackets to start a second command. Now, inside of these brackets, we're going to put something similar to a digital read, but it's going to be a digital write. Oh gosh. Digital write. Now, if we read from the button, what do you think we're going to write to? Hopefully you guessed it, we're going to write to the LED, or at least the pin that the LED is plugged into. Because honestly, the computer doesn't know exactly what's plugged into it. It just knows that it's sending power to something. It knows that it's something, we've told it up here that it's in output, so it's something that's power hungry. So we're going to do a digital write to the LED, which is our output, and is in pin 7, and we're going to put that as high. There we go. So right now it says if digital read button pin 11 is high, then make the LED high or on. Then we're going to do something called a delay, and we'll do 1000 milliseconds. And this basically, 1000 milliseconds is 1 second, so 2000 milliseconds would be 2 seconds. So there we go. So now we have the if the digital read of the button is high or on or pressed, current's flowing, which would be on, then the LED is going to be high for 1 second, and then this have a delay for 1 second, and then we're going to do I can actually copy and paste. Ah, crap. Now we're gonna set this to low. Now, all caps. Now it's important that you do things like this to close off statements because you want it to go off. The computer might get a little confused. So then we're gonna do, so yeah, that's basically gonna end this part of turning it on. But what is the computer gonna do if it's not being pressed? So we need to add a else. So we're gonna add else at the end of the brackets that set up this if statement, so everything that's in the if. And we're going to say else, if anything else is happening, digital write LED low, which means the LED is going to be off. If anything else than the button is being pressed, the LED is going to be off. That is basically the code, so we can compile it, make sure it's all good, save that. Let's make sure it's 100% good. Make sure we didn't forget any semicolons. It says it's good. So now we need to upload to our board, and I will show you guys what the final product looks like. So one more time we can run through this. Basically we have our we're telling the computer what LED and button is, and then we're telling the LED and button values are actually pins, and then we have the digital side of the code reading these pins, in turn outputting to the pins, turning on our LED based on what we do with the button. Okay guys, so after we've written the code, it might make a little bit more sense. Pin 7 is trying to be sensing the LED, and pin 7 is trying to send the current to the LED depending on what it's sensing from pin 11. So let's go ahead and press the button and see what happens. There we go, the light's going to go on for a little while. Give it a second. And then it turns off. Let's try it again. So when I press this button, it says pin 11 says, oh, I'm sensing something. That's the digital read. It's reading, and it's reading to sense a 5-volt current. It's reading for that 5-volt current. And then the digital write is writing out power to this LED. So when I press the button, we're having the digital read from the button and then the digital write out to the LED for a little bit of a delay. So that is basically the same concept. So basically, that is the big idea of this, is that you can use a digital write and a digital read to basically control anything you'd like using an input source, which would be our button, and then the output, which would be the thing you're powering. So this doesn't have to be an LED. This could be a screen, an LCD screen. This could be a speaker module. This could be anything you want. This, you know what I mean? It doesn't have to be an LED. So what if we took that concept into a pneumatic cylinder and decided we're gonna replace this LED with a pneumatic cylinder? We can do that. We might want to change out the resistor and also possibly even put in a little relay, which I actually talked about in another video, card up above. If you want to watch that, how to use relays. I made a cool flickering light. But yeah, so you might need to use a relay depending on the type of solenoids you bought. I will have all the parts listed in the description below, so if you guys need any of that, it'll be in the description below. And also, I'm gonna be posting all of the Arduino code below, so you can quickly copy and paste. And so if you want to get to the just testing it out and see if it works for yourself, then you can just copy and paste the code, and then you can expand with your own projects from that. So let's go ahead and take the LED concept where we press the button and put it into real life with a pneumatic cylinder.